Let's find the derivative of this. Let's start with the domain, though. So in this problem here, I have a radical, but the radical is also the argument of a logarithm. So when I have an even index radical, I know that x has to be greater than or equal to 0. But when I have an argument of a logarithm, x has to be simply greater than 0. It cannot be equal to 0. So in this case here, I have to treat this as the argument of the logarithm. That's more restrictive. So I know that the square root of x plus 1 has to be greater than 0. And if I square both sides, I know that x plus 1 has to be greater than 0. And if I subtract 1 from both sides, I know that x has to be greater than negative 1. So in interval notation, I would write that negative 1 infinity, parentheses on both sides, because we always have parentheses with infinity, and I'm not including negative 1. So this is the domain of my function, and I think I'll just write it here, x greater than negative 1. Or really, as I prefer it, I put D domain, and I use the interval notation. Much prefer interval notation. So now I need to find the derivative. So I'm going to use this derivative rule that I just wrote there. And I'm going to end up using the chain rule too. But I think before I do that, I'm going to rewrite this as log base 10 and make my argument x plus 1 to the 1/2. That makes it a little bit easier for me. And let's just make sure we know that this entire thing right here is my argument. So f prime is going to equal 1 divided by, well, my x in this case is my whole argument, so divided by x plus 1 to the 1/2 times the natural logarithm of my base, which is 10. Now, that took care of my outside function. Now I have to deal with my inside function. So my inside function is times, well, I'm going to use the power rule, 1/2 x plus 1 to the negative 1/2. And then, I guess technically speaking, I have another inside function, but the derivative of that is just 1. So it's really kind of something that I can ignore. So I now have the derivative written out. I'm going to try and simplify it a little bit. Well, if I multiply this 1/2 into the front part right here, this is going to be f prime x equals, so it's 1 over 2, and I have x plus 1 to the 1/2 ln 10, and then this x plus 1 to the negative 1/2, well, that's the same thing as putting x plus 1 to the 1/2 on the bottom, because it's a negative exponent. Well, what do I have? I have x plus 1 to the 1/2 times x plus 1 to the 1/2. I'm going to add the exponents together. So I'm going to get f prime of x is equal to, well, only 1 on the top, 2 x plus 1 to the first, because I add the 1/2 and the 1/2, ln 10. So that's the derivative. Let's just take a peek at the domain. The domain up there said x has to be greater than negative 1. Well, if I just looked at it from the derivative standpoint, I just have to make sure that x is not equal to negative 1, but x greater than negative 1 is more restrictive. So that's the one that I have to use. In this case, if I was just looking at the derivative here, x could be a negative number or something like that, but With this, it's telling me no, x has to be greater than -1, not just not equal to -1. So I have to make sure my domain is correct, and this is the proper derivative.